We now consider this, again, conceptual problem about interpreting the median, the mean, the range, and the standard deviation. The median is basically going to be the middle number, or if there are two numbers in the middle, the average of the two middle numbers, as we saw in problem 1.4. The mean is going to be, well, you know the definition, just add them up and divide by the number of entries. That's just kind of a balance. So for example, to draw a picture, so suppose we have number line, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we go up to 11 and 12. Okay, so suppose I have 3 entries in the list. So 1, 2, and 12. The median of 1, 2, and 12 is 2. That's the middle number. The mean is not going to be 2. The mean would be 1 plus 2 plus 12. If I had 1 plus 2 plus 12, that's 15. Divided by 3 is 5. So you imagine that if I have blocks here, if I put a balance here, the 2 blocks here would be perfectly balanced by the 1 block that's way over here because it's so far away from the fulcrum. So the mean is kind of a balance between as opposed to just simply what the middle number is. Part C, the range, would be just simply the largest number minus the smallest number. So that would be, in this case, 12 minus 1 for 11. The interpretation of the standard deviation is that it gives an indication of spread that's a little bit more subtle than the range. So the interpretation of standard deviation is as follows. Suppose you have the average here. Suppose you add one standard deviation and you subtract one standard deviation. Then ballpark estimate, about 68% of the entries, about 68%, ought to lie within one standard deviation of the average. And if you go up another standard deviation and go down a standard deviation, then in this bigger range, something like 95% of the entries ought to lie in this bigger range. So about 2/3 of the entries ought to lie between one standard deviation of the average, between one standard deviation down and one standard deviation up, and about 19 out of 20, 95% ought to lie within two standard deviations, either below or above. So this is a way of being able to estimate a standard deviation without actually computing the standard deviation.